All right, two problems. We're going to do these by elimination. And this is a method you should know too. More because it leads us into matrices than just for solving these. I want to start with this one. I know a lot of you have probably seen this. In fact, if you asked most people that knew how to do this to show you how to solve this, this is probably the method they would show you. And let's start with this one right here. And if two things are equal to each other, it means they're actually equal to each other. And remember, you can add, subtract, divide, and multiply the same thing to both sides of an equation. Now, what do I mean by that? Well, for example, let's just suppose I get the idea, and you might wonder where I get the idea, but suppose I get the idea to multiply both sides of this first equation right here by 3. I don't have to say why I'm doing that. All I have to say really is that is an allowable maneuver. It's justified because I'm doing the same thing to both sides. Now, consider this as one object. This is a system of equations. And if you consider these two together, you can consider it as one thing. And I'm going to write down another thing here, which is equivalent, which is the same as this thing. Let's multiply this out. 9x plus 3y equals 15. And this one we'll leave alone. Now again, what I'm saying is this is the same thing as this. They're the same thing, the same object. Now looking at this, you might get an idea. And the idea you might get is as follows. Since this equals that, they are the same thing. I can add this to the left side of this equation, and I can add this to the right side of the equation because they're the same thing. Now, if I take this and I add this, what will happen? Those two will cancel each other out, and we'll get 11x. And over here, we'll get 22. Very nice. Why? Because now we only have one variable. Easy to solve. Divide both sides by 11, x equals 2. And now we can back substitute. We can go back wherever we want to go back and figure out what y is. In fact, I don't know, just for fun, I'll go back to this equation right here. Let's say 2x, oops, wait, we know what x is now, right? It's 2. So I'll put a 2 in there, minus 3y equals 7. That's 4, subtract 4 from both sides. And we would get 3, and y equals negative 1. Okay. Oops, circle the wrong thing, right there. This is the elimination method. And the key idea with the elimination method is that you're trying to eliminate one of the variables. Say there's an x and a y. We would only like to have an x or only like to have a y. We do that by adding one equation to another equation. And usually first we prepare one of the equations by multiplying it by a number so that we'll get this nice sort of canceling. Here, I don't know, it was essentially obvious. It didn't seem like it was that difficult to do. But what about this example here? Let me see, make sure this is on screen, yeah. Just to clear our minds, let me erase this example and we'll look at that example right there. This example here I got from the book. This is chapter 4. I think it's 4.2 or 4.1. The book does it one way, and I want to show you a different way, and then I'll tell you why I want to do it a slightly different way from the book. What I'd like to be able to do, well, now I'm thinking about how the book does it, and I have to admit it's kind of sweet. It's kind of nice the way the book does it, but look at these two right here. What I'd like to have happen is I would like to multiply this equation by some number so that we get, well, either a 7 or a negative 7 here, because we can add or subtract. Because you can add, subtract, divide, and multiply the same thing to both sides of the equation. How about if I multiply both sides of this equation here by 7/4? And I'll leave this alone. Now what would that give me? This times this, 7x. This times this, 21 over 4, y equals, this times this, 63 over 4. This equation I'll leave alone. This is an equivalent system. Last time I added one equation to another. This time I want to subtract one equation from another. It doesn't really matter which one I subtract from which one. Let's just take this one and I'll subtract this equation from it. Now, you have to be careful in the following sense. I'm going to subtract this. And that means I have to subtract each one of these terms. Now 7x minus 7x, fine, that's gone. What would I have left here? Here, I'll write it down. We have negative 21 over 4 y minus 2y. Now I'm subtracting, right? So over on this side, we have 63 fourths minus negative 6. Well, when you subtract the negative, you add the positive. So what's 63? I'm waiting for someone to find the mistake that I made in the previous video. We'll see who can find it. I found it. But plus 6. So what does that give you? I'll wait. Now you see, you should do it yourself. Don't trust anyone to do it. As far as I can tell by doing it, we need to do 63 plus 24, which should be 87 over 4. Okay. Hey, that's the hardest part of the problem so far. Let's combine like terms here. We'll combine like terms. So when we add these two, what do we get? Make sure you're doing this. Make sure you're doing this. So negative 29 over 4y equals 87 over 4. And I guess, what's that expression? Darkest before the dawn. We go ahead and flip and multiply. And here, let me just go ahead and show this. 87 over 4 times 4 over 29. Granted, okay, it's going to be a positive divided by negative, so the answer is going to be a negative. But what happens here? Those two cancel each other out. And lo and behold, 29 goes into 87. Now, this being a problem from the book and being an introductory type problem, it's actually not surprising that the final answer comes out to be a whole number. Okay, so here we get y equals negative 3. And then I can back substitute. Now, what I could do is I could actually go back, if you want, this would be more work, but you could go back to the original problem and I can multiply both sides of this first equation by something so that when I add or subtract the equations, the x's cancel out. And then I would solve, oh, I solve for y, sorry, so the y's cancel out and I would solve for x. That seems like a lot of extra work since I know that y is negative 3. Let me just come back to this equation right here, and we get 7x plus 2 times negative 3 equals negative 6. So 7x minus 6 equals negative 6. Let's add 6 to both sides, and x equals 0. Okay, now, like I said, the elimination method, you're not going to see it in this course. Most people will tell you, and they're not wrong, that this is easier than doing the substitution method. This is not the easiest method, or at least it's not in general the most efficient method, but the most efficient method we're actually not going to do in this course. But this is going to lead us into the concept or the idea of a matrix, which has such a vast array of applications and uses. Sometimes I don't even know where to begin. Whether it's the movie The Matrix, so I haven't even written down a matrix yet, but I will in the next video, and we'll talk a little bit about matrices. But wow, they're used in economics, engineering, just medicine, you name it. So the elimination method here can give us an introduction into matrices. So next video we'll deal with matrices. In the meantime, make sure you practice the problems from chapter 4, and now practice both with substitution and with elimination. If you had to pick one to emphasize more, emphasize substitution more. Okay, all right, thanks. I mean, till next video.